Well, thanks so much, Diana. The war stories, however, should be those of Irwin Jacobs, a true technology visionary. And I thought, Irwin, we could start by the parallels of a central task in Arthur C. Clarke's career and your career. Clarke became famous for his observation in the 1940s that you could use geosynchronous orbits to establish satellite communications as a key part of the global communications infrastructure. And you had the vision that CDMA could be the fundamental building block for a truly digital mobile, eventually broadband system of communications. When you undertook that vision, you were doing technology forecasting. It was a complicated task. There were lots of skeptics. There was a famous Stanford professor who said it defied the laws of physics, if I recall, and somehow it still worked. I guess that's because you're an engineer and you don't always pay attention to physicists about these matters. But could you share with us this exercise of insight? How did you make that technological forecast? What was the key insight that gave you the confidence to make this bold claim?
Well, there's not one key insight, unfortunately. There's a whole series of things. If you're going to come up with a concept, take it into a technology, get into development and production, and then overcome competition. So there's a whole sequence of steps that you must go through. The first, in some sense, may be the most fun, the coming up with the idea of using CDMA, code division multiple access. And that happened very shortly after starting Qualcomm, and it was during a drive back from Los Angeles where I had providing some consulting advice to Hughes on a mobile satellite communication system. And the issue with mobile is that you're usually by yourself. And so it's just a single conversation you have to handle. You can't bundle a number of them together easily. When you're speaking, much of the time, for most people, you'll listen part of the time to the other half of the conversation. And you pause yourself to think, and so there are gaps in the conversation as far as the time you're using. But with most of the traditional technologies for communication, you can't easily give it up your channel capacity, your use of spectrum. You can't easily give that up and get it back quickly when you need it, when you want to start talking again. And so driving back from Los Angeles from this meeting with Hughes, I suddenly realized that perhaps there is one technology that does allow you to do it, and that's code division multiple access. And let me give you just a quick insight into that. Basically, each conversation that's going over that spectrum has its own code, and you might think of that as each one having its own language. And so there are people, basically you can think of in the same room, carrying on conversations in different languages. You can understand the person near you using the language you're focused on if there isn't too much noise around you. And so if there's enough signal to noise background, you can make out the conversation. The problem is that sometimes people could be shouting or doing the wrong thing. In the technology, it's called power control. You can't allow the other users to use more than just enough power to talk to you. But the positive aspect was that if you stop talking, even for a short while, you stop generating the interference. And that allows, on average, more people to be able to use the system, or the operators can sell more subscribers in that same amount of radio spectrum. So that was kind of the initial insight that we can take advantage of the pauses in the speech to be able to let others use that spectrum essentially immediately, but we can still get it back when we need it. If we can control, for example, the amount of power that these other users are using. They're not shouting in your ear, or in the case of mobile transportation, you are driving in a car, say, you come out from behind a building that's between you and a cell site, suddenly it's shouting at you. You have to adjust things very, very quickly so you don't shout back at them. And so there's a number of issues. What had happened is that there are laboratories, developers around the world that had looked at the use of CDMA before us and couldn't solve that power control problem. They couldn't solve a couple of other problems and had given up. And so we came up with the idea that, yes, I think there are good ways of solving the problems. That was the first technical issue. And we didn't have, unfortunately, at the beginning of the company, enough money to pursue it. We had to wait to develop a different product, get a cash flow in from that product. And interestingly, that product was a satellite communication system to provide communication and position location for the trucking industry. So it used the satellite that Arthur Clarke had proposed, a geostationary satellite, many years before, in 1945, I think it was. And so we were able to make use of those satellites to develop a communication system. It had its own technical issues, I won't get into those. And we did launch it in October of '88 with the very largest trucking company in the US. That gave us some money to go back and look at CDMA again. And one needed to do some computer simulations to kind of think through a few of the other issues with cellular and make sure you hadn't missed something and that it had advantages. And so that took a few months. Unfortunately, in those few months, the rest of the world decided to standardize on a different technology called TDMA. So the second challenge was one of schedule and timing. Well, how do you overcome that? One of the things we did was to arrange a meeting with perhaps this number of people from the industry and tell them about our ideas on CDMA. And I thought there was about a 50-50 chance that somebody was going to raise their hand and say, you forgot that particular idea or problem, but nobody did. But nobody was convinced either. This was the days before PowerPoint, so you were using little transparencies to show it off. You had to go build a system. And so, again, like most startups, you work day and night. In about 4 months or so, we put together a demonstration CDMA system, invited everybody in to see the system. It did have one hiccup. Somebody, just as I was getting ready after explaining the issues and sending out people to go and listen to both ends of the telephone link using CDMA, one of the engineers in the back of the room raised a hand and kind of indicated, keep talking. And we had a problem with using a GPS satellite, which was still in exploratory phase for synchronization. We had a problem, took 45 minutes to recover. There is a great advantage to having been a university professor. Many advantages, but one great one, you talk easily for 50 minutes. And so I did talk through that. I don't think anybody realized that I was stalling, in a sense. And then they went out and everything worked well. And so we got through that first issue of being able to demonstrate that it did work. But the question then is, first of all, does it have the right level of capacity? And secondly, can you build a demonstration, a real commercial system? That first system we demonstrated required a van to drive this mobile phone around. Wouldn't be too commercial. So the next step was to go and build a unit that is commercial sized. To do that, you need to work with integrated circuits, develop the integrated circuits. And that was another aspect that a lot of our competitors or the other people in the industry had said CDMA, even if it does work, is too complicated and you can never be able to build a reasonable priced phone. But they had forgotten about Moore's Law. You never design using today's technology if you're trying to do something in a couple of years. You look at what it might be 2 years out. And Moore's Law says that the number of transistors that you can put, or he observed it, it's not really a law, that number of transistors you can fit on a piece of silicon will about double every 2 years. He said 1 year, but it's really been every 2 years. He came out with that in about 1964 or 5, and it's still ongoing. It's doubling every 2 years ever since. And so we're able to look ahead and say, yes, we can build some integrated circuits. They'll have the right density. They'll come in with the right price point. And we went ahead and did that. And we're able to demonstrate that we could come up with commercial equipment. The final problem was competition. There's a lot of other companies out around the world competing with you. And so the final step in becoming confident that we're onto something was, how do you beat the competition? Well, luckily, the world realized that for cellular, just having voice wasn't adequate. We had been working on it earlier, but the rest of the companies and users caught up with the idea, and operators. You needed to have mobile data transmission. You had to have access to the internet, high-speed data efficiently. What technology could be used? And finally, the world agreed that CDMA was the right technology. It was at that point I realized, okay, we've overcome the competition and we're on a good path. I'll finish up with one point. There's always a question of business. Can you make some money trying to do this? And one aspect is, what's the size of your market? And so we began to think about, what's the size of the cellular market? And of course, you come out with crazy big numbers. So the first thing, let's divide that by 2. Still too big, divide by 2. We divided by 2 a number of times before we could work out a business plan. Luckily, as it so happened, we had to put all those factors of 2 back in. It just kept growing. So all worked out very well in the long term.
So technology forecasting in the real world is, as you say, a multi-step exercise, because a good idea isn't enough. Let me push you in the spirit of Diana Dugan's comments in your introduction about left brain, right brain, the arts, and, if you would, engineering and technology. Has your experience as an entrepreneur in the world of technology shaped your view about how you and Joan do your philanthropy in the arts, and you try to build the arts in San Diego, for example?
Well, first of all, when you're with a startup and trying to build a company, and there's, the time requirements are very, very large. Family requirements are very large. We have 4 sons, and they were growing. And somehow you need a little time for a break. And so how do you take that break? Well, one of the things that we thoroughly enjoyed together was going out and enjoying music, and particularly symphony, jazz, chamber, popular. But that break. And when you're listening to music, you can focus on that, and these other issues you can set it off to one side. So that turned out to be very valuable. When we were marketing CDMA, cell systems, you don't do it in one location, it's everywhere in the world. And so we had to be going out throughout the world, traveling, and luckily Joan was able to travel with me a good part of that time. What do you do when you have a break between business? If there's music, if there's theater, you go. Or we also enjoyed going out and looking at art. And so it was something we developed that was associated with the technology and the time, but it was partly a way to break from the time pressures. We fell in love with it. The technology, luckily, supports a lot of those aspects, because now you can provide music worldwide, you can provide visually very good shows, operas, worldwide, theater, and so the technology has come together with the love of those arts.